K10 5-watt laser engraver. Let's make some colloidal nanoparticles with it. I'm Tom, Alchemy Wizard. Let's get into it. Now, if you've been following along with my laser series, you'll have some idea of what's going on here. About a week or two ago, I got the K10 5-watt laser engraver, and from a suggestion from one of my viewers here, said that we should try the laser engraver to see if we can make nanoparticles out of it. And of course, if you've been watching the shorts and stuff, you'll see that we definitely been able to make nanoparticles out of it. But there's a lot to cover on the thing on how to make nanoparticles out of it. It's not so simple as you just put the sample in there and push the button. There's different settings for the laser. There's two different kinds of methods for using for creating the nanoparticles. So let's take this part 1 video here and just go into the basics. But anyway, it comes with glasses in the right frequency. In theory, you could leave this open and then use the glasses, but to be perfectly honest, when this laser is in 100% output mode, you still need the glasses to look at the light from here. And this is the shield, which when you lift this shield up, the laser will stop working, which is really good. It's a nice, nifty safety feature. The other thing is safety. This thing is quite bright. The laser light, literally, when you got it on 100% laser mode, it is flinging all over the place. Now, luckily, this shield protects the reflective laser light, because naturally, we're not etching a piece of material. We're bouncing a laser off a piece of metal usually, and it reflects back up. So the laser is bouncing off and on and off and all around here. And I have to say that this shield that they have designed here works really well, except for right down here in here. There's an air. This is an air hole in order to keep the laser cool, so you really can't block it off. But if you have the laser too close to the end of the desk, the light will actually shoot down onto the ground. And that's okay, I'm not on the ground, but the dog is on the ground, and so we do have to be careful for our pets. So I try to keep this back further on the desk so that the laser light that does leak out here and bounce in here just bounces back in and doesn't bounce onto the floor. One of the earlier things I found out with the laser is it will burn a hole in the bottom of your desk. If for some reason your sample that you got in here that you are laser etching, the laser decides you hit it by mistake and you don't realize it, and the laser is still going, in the etching its thing, all of a sudden it's going to be etching your desk, and yes, it will etch into your desk. Could actually even start a fire. So the first thing I recommend is either to get, this is a piece of a slate coaster that I have in here, so that in case it does miss the target, the only thing it's going to be doing is etching the slate coaster. It actually does etch. This is the slate coaster I etched, Alchemy Wizard, and I got my YouTube channel down here. And you know what? This is going to make a great Christmas present. I'm going to order a bunch of these things. I'm going to put a person's name up here, and my Alchemy Wizard logo with the address for the website, and I'm going to give them away as Christmas presents. There are reasons to use the laser. The laser can be good in instances where we can't make nanoparticles. We're unable to make indium with low voltage DC. But the interesting fact about the whole thing is that the laser indium seems to be twice as powerful as the plasma arc indium. Is it possible that colloidals made with the laser are much more powerful when taking in the body than colloidals made with low voltage electrolysis or with plasma arc? Now, the other thing about the laser is each of the metals are different, because there are two different modes of operation with the nanoparticles. You have the materials that we can laser ablate, called laser ablation, where the laser is hot enough to melt the material, and that turns it into nanoparticles. And that works the best and the fastest. With the indium, we're using laser ablation, and that's a whole one set of settings where we're melting the material, we create the laser ablation, and we create the nanoparticles. And that goes relatively fast. We're looking at about 40 minutes getting almost an 18 or 20 parts per million solution of nanoparticles. The other thing we have is the metals that we cannot reach a high enough temperature to melt because the 5-watt laser isn't strong enough. In these metals, we need to use the electron excitation mode, which is a lot longer than the laser ablation mode. For example, I'm into about 10 to 20 hours making this stuff at 50 milliliters at a time. So when it comes to harder metals like gold or silicone, we can't laser ablate that. So we have to use the other method, which is a lot longer method to convert into nanoparticles, but it does convert into nanoparticles. So I've verified it. The weight comes down on the materials. We're losing the material. It's going in there. If you see my short on showing when I did the silicon, and you could see the little nanoparticles firing off into the distance, little streaks of light going off into the distance as the electron excitation removes the material a little bit at a time. That is the first of several parts introduction to making nanoparticles with the laser. I'm Tom, Alchemy Wizard. I'll talk to you all again